Okay, so here on page 63, we are going to talk a little bit about standard form and vertex form, okay? In the first example, we are going to go from vertex to standard form, okay? And the way we're going to do that is by basically we're going to multiply this out. And then in the second example, toward the bottom of 63, we're going to go from standard, if I could spell it right, A-R-D, to vertex. And when we go from standard to vertex, we're going to do that, we're going to achieve that by doing this thing called completing the square. But we'll get to that in a minute. First, let's look at the example at the top, going from vertex form to standard form. Now, if you look at the function f of x equals 2 times x minus 4 squared plus 3, the first thing we're going to do to go from a form that looks like that to a standard form is we need to take care of this part here. We need to multiply that out. Now, remember what something squared means. It doesn't mean to just square everything that is inside the parentheses. What it really means is I need to do x minus 4 times x minus 4, right? Isn't that what squaring something means, multiplying it by itself? All right, so you see that the 2 is still down in front, but when I FOIL this out, x times x is this x squared. When I go outside, x times negative 4, let me just kind of write this over here. So I had x squared on the first part of this, and then when I went outside, that gives me a negative 4x. My inside is a negative 4x, and then my last is negative 4 times negative 4, which is a positive 16. Okay, so as I move down here, here's that x squared. Okay, if I combine the like terms, a negative 4x and a negative 4x is a negative 8x, and then plus 16. And then that plus 3 just came down from my original. So this 2 came down, and this plus 3 came down. So that x squared minus 8x plus 16, that's just a result of doing x minus 4 squared. All right, so now that we got that out of the way, now we're going to go ahead and we're going to do the distributive property. So as I distribute this 2 through, 2 times x squared is 2x squared. If I distribute the 2 through here, I'm going to do 2 times the 8x. And then as I distribute through here, I'm going to have 2 times the 16. Now, a lot of times we wouldn't write it like that. We wouldn't actually write that out. We would just do 2 times x squared is 2x squared. 2 times 8x, we would just put a 16x here. And then we put a 32 here, 2 times 16. You know, you might not do that step. This step here. Okay. Once you've multiplied that out, now you have a chance to combine like terms, because 32 and 3, well, those are like terms. They have no variables, no exponents. So we would just combine those to make a 35. So in the end, 2x squared minus 16x plus 35, let me put that f of x here, f of x equals. So those two are congruent. Those two are equivalent. All right? They're in 2 different forms, but that is the same thing as what we started with, which was 2 times x minus 4 squared plus 3, if I can squeeze it in, which I did. They're just in 2 different forms. This is standard. This is vertex. So to go from vertex to standard, we're just going to multiply. So let's go down here to the bottom. Now they give us something in standard form, which right here, this is standard form. And they want us to put it in vertex form, which we know vertex form to look like this. We're going to use this process called completing the square. Okay, and here's how this works. Basically, what we're going to do is we are going to take the first two terms in this trinomial, which is the x squared plus 6x part, and we're going to kind of pull that aside, and then we're going to take whatever the constant term is, and we're going to move that over to the right. Okay, so as you look at the way they have this notation below, that the first two terms are part of their own parentheses, and then the third term, that gets moved sort of to the outside of the parentheses. And the part that's in the green there, that's the completing the square part. Okay, this is just a setup so that in our next step we can complete the square. So this is what I'm concentrating on right here. What I want to do is I want to create a perfect square trinomial. Meaning, let me just give you a side example of what a perfect square trinomial is. If you had x plus 2 times itself, or x plus 2 squared, that would be the same thing as taking x plus 2 times x plus 2. Alright? And when I multiply this out, when I do FOIL, first outside, inside, last, I get x squared plus 2x plus 2x plus 4. And when I combine those together, I get x squared plus 4x plus 4. This is a perfect square trinomial because it is a product of multiplying something times itself. So let me say that again. A perfect square trinomial is a product of something times itself. So what I'm trying to do, what my goal is with completing the square, is to create that situation. Something times itself is my goal. Okay, because we know that when we're in vertex form, this part here, right there, the x minus h squared, I want to create that. So here's what I'm going to do. In order to create a perfect square trinomial, you know, this 9 ends up being the number I use. Well, why would I use 9? Well, when I use 9, that's x plus 3 squared to give me x squared plus 6x plus 9. Now I'm a little bit ahead of myself there, but that's kind of where we're headed. So how do I randomly come up with 9? Well, here's how. You take your middle term, which in this case is a 6x. Whoops, let me undo that. Okay, I'm going to take the 6x. I'm going to take 6, I'm going to cut it in half, and then I'm going to square it. You take the middle term, whatever that coefficient is, in this case it's a 6, cut it in half, and then square it. 6 cut in half is 3, 3 squared is 9. So that's how I get the 9 here. Now I can't just randomly introduce a 9 and add it to a function, because then I'm ruining the equivalence, the equality of the equation. So if I'm going to add 9 to a function, I also have to subtract it from that same side. Because really it's like I'm adding 0, right? 9 minus 9 is 0. Okay? So by doing this, I take the middle term, I cut it in half, then I square it, and that helps me determine that, okay, 9 is the number I need in order to create this perfect square trinomial. I have to use 9. No other number will work. Because when I use 9, now that part becomes x plus 3 squared, which is a very important part to being in vertex form. Out here, I'm just going to combine my like terms. Okay, a positive 4 minus 9 is a negative 5. So we have taken a standard form function, and now we have changed it to vertex form of x plus 3 squared minus 5. Vertex form is what we've created from standard form. The key to all of this, the completing the square thing, the key to this is right here, the perfect square trinomial. You have to create that. That's the completing the square part. Perfect square trinomials.